So let's price some bonds. Now, to begin with, let's talk a little bit about the sample problem we've been working on uh, in my lecture notes. And so I just wanted to remind you of some of the journal entries we already have reviewed, um, and that basically reflect the three scenarios we'll be talking about. As you might remember, the first one here, the scenario at face, means that there's no discount and no premium needed, because in this case we're saying that the contract rate is equal to the market rate. So the return in this case, in these bonds, if you might remember, the contract rate was 12% and the market rate was the same. Oops. That meant that there's no need to worry about providing either more or less of an effective return to the investor. The investor will get the 12% that they require based on the market rate strictly from the interest payments, which also are gonna provide the investor with 12% return, and that's it. You're done. So there's no need to do any adjustment to these proceeds right there. Now, in a premium situation, uh, let's talk about this one first. Notice that here we're saying that the proceeds are going to be only 96,406, but we're still going to be, if we're the issuer, we're still going to be liable for the full 100,000. That difference is referred to as a discount on bonds payable. Now, the investor will still get the interest payments that will generate a 12% return on the bonds, but the market rate in this situation, as you might remember, is actually at 13%. So that means that the bonds are one percentage short. And so to make up for that, since we cannot change the bond itself, that 12% return is already through the interest payments is already fixed. The only place we can actually make up for that additional interest that is needed by the investor is to reduce the proceeds, and yet at the end we're still going to be giving the full amount of 100,000 to the investor. That's how you generate the extra 1%. The reverse is true for the premium. In that case, we're still going to provide a return of the face to the at the end of the life of the bond to the investor. We're going to be returning the whole face of $100,000. Yet they provide, or they pay initially, a price of over the face. In this case, by $3,769, and the difference there we refer to as a premium. In that case, the premium helps to reduce our interest expense. So if you might remember this, the contract rate again is still 12%. That never changes. But in this case, the market rate was 11%. And so the bond was giving away too much. And so we need to make an adjustment to the price to make up for the difference. Now, this is the setup that we've used in the actual sample problem in a different part of the lesson for this chapter. Now, I'm going to actually then sort of give you an overview of the whole process in a second with a very simplified version of a problem for a bond. And it will be more simple than this, but I hope that it makes sense conceptually at least. So to begin with, I'm going to show you this little graphic here that I'm not a great artist, so this is what I came up with. Betty is the borrower, which is the reason that I have a B for Betty. So she is the issuer of the bond, and Ivan is the investor. And again, we have the three scenarios, and so we're going to talk about these in order. Uh, let's talk a little bit about the first the cash flows that we're talking about for this specific bond. The bond in all cases is a $1,000 bond, one single period of 1 year with a 10% contract rate. Scenario one is at face, meaning that the market rate is also 10%. So as you already know, there will be no premium and no discount in that case. For the scenario at a discount, the market rate is higher at 12%. And for the premium situation, the market rate would be 8%. So these are the rates that the investor Ivan is looking to get from some kind of investment. And so he found, I'm sure, various investments, and now he's focusing on Betty's bonds. Now, the bond, whatever the bond says, is only one portion of the return. If he needs more or less than that, then actually there will be an adjustment to the price. So let's look at the first case. Let's just look at the first of all, before we do the actual calculations, let me just give you the cash flows that come from the bond, and they are represented in red, and then the cash flow from the investor to the issuer is in blue. Notice that for the bond, the cash flows that will go to the investor, to Ivan, are always the interest, and at the end of the term of the bond, the investor, or Ivan in this case, always gets the face amount of the bond. So those are the two types of cash flows, from the issuer to the investor. Now on the other side, once we take care of the cash flows and we kind of project out what they're going to be and make a calculation, then we're going to be able to then eventually figure out what's the initial price of that bond, what is the amount that Ivan will give to Betty for those bonds. So that's the blue line, and that's what the cash was for each of those cases. Now let's look specifically to the case for at face. So notice again that for this specific bond, the principal is $1,000. The interest rate for the year is 10%. We're looking at the full year, so it will be 12 over 12. The interest for these bonds is $100. So given that, or I already know that there's no premium and no discount, the only amount that Ivan will get on these bonds is the interest. So it will be $100. You divide by the investment of 1,000, which is the same as face, as you remember, there's no premium and no discount. That means that you get that Ivan gets 10%, and that's obviously what he's looking for, since the market rate is the same as the contract rate. And notice that down here I have the steps. You determine the cash flows, which we did in the previous slide. Determine the ROI from the interest, which we just did above. And then determine whether there's the ROI and the market rate are the same, where they are, so there's no need to make an adjustment. And so the proceeds to Betty are the same as the face amount. Now keep that in mind, that process. Go to the next one, and now we're looking at a discount scenario. In that case, the interest again up here is the same. That doesn't change. It's still $100, and the investment is 100 over 1,000. That's actually a 10% return. If that's only a portion of the return at this point, because we know that 10% is obviously lower than the required 12%, which Ivan wants and needs based on the market rate. Now we know that the bonds offer 10% through the payments, so to make up for that differential between the contract rate and the market rate that he wants, we need to make an adjustment to the price. So the proceeds are reduced to $982. Now, how do I know that the discount has to be $18 specifically? I don't actually know it offhand. I have to actually do a calculation, which I did, and that's the amount I came up with. And the calculation would come, the mechanics of the calculation will come in a different lesson, which follows this one. So given that, let's go back and say this. B here says Betty's bonds terms are fixed, so we cannot change the bonds, but we could reduce the bond proceeds or the loan amount itself to 982. That means that Ivan will receive the full 1,000 at the end of the term of the life, even though he only loaned 982. So it's a differential there of $18. So if you come down here, you know that Ivan will earn $100 from the interest payments plus 18 more through the discounting. So the total return to Ivan is 118. Total investment from Ivan is 982. So now that's how you come up with a 12%. 10% through the interest payments and 2% through the discounting. Similarly, if you look at the scenario, the premium scenario is the same thing as previously, but in reverse. We still have the 10% sort of initial calculation to kind of figure out whether we're near the market rate. Well, we know we're not, because 10% is actually higher than the 8% that Ivan would require based on the market rate. Now, Ivan would be obviously very happy, but Betty would not be. It's just too much. She's giving too much through the bond, so she has to make an adjustment. Again, doing a similar calculation as we discussed in the previous slide, I know that the amount will be 1,019. That's the overall amount of the proceeds that needs to be to reduce the effective rate from 10 to 8%. And at the end of the term of the life of the bond, Ivan still gets $1,000, even though he loaned us 1,019. Well, that differential, $19, actually goes against his initial return from the interest payments of $100. So the overall return will be only 81. If you divide by the 1019, then that's how you actually prove that will be 8%. And that will be what the market rate is. And again, the point about this is that you get $100 through the interest payments, and you actually reduce it by the premium that was paid initially. And so this sort of proves how you do the adjustment to match the market rate. Here is the summary of all three scenarios. Again, cash flow, $100, and 1,000 at the end to the investor, and then 1,000 is the actual proceeds. The discount, you have $100 interest plus the 18 discount. In total, the pricing is 982, and the investor still makes the 12%. And similar process for the premium is 8% here. Now, let me go back to the initial slide that showed the different amounts for either the premium or the discount. Now, I will show you, just focusing on the discount scenario here, how you actually apply the conceptual explanation of that we just went through with the other simplified example to figure out what is the amount of the differential for this example here. So here's how you work it out. This is one way to do it. And so notice that in this case of this bond, the principal or the face is actually $100,000. So that's obviously bigger than the example that we had initially or previously, the $1,000, but doesn't matter. There, in this example, there's also a market rate of 13%. 5 years, but there are 2 periods per year, so there are 10 periods total, with a 6-month rate of 6.5%. And given the the rate and the periods, I just simply calculate the interest payment per period, and sort of just place them on this timeline. So you see here, there's actually interest payments more than one. Our simplified example only had one. Here we have actually 10. And then we also have one more at the end, the return of the face to the investor. So you simply just do a present value based on present value factors. And these cash flows here become, or the present value of, of that cash flow becomes 56,469. You do the same thing for each of these, and you end up with a sum of all of these of 96,406. So now you actually present value both the annuity represented by the series of interest payments, and also the face together. You end up with this amount as the price for those bonds. Again, it's very similar to what we just did in the simplified example, except that you have more payments, and it's simplify more payments, and a different interest rate, because we're talking about half a period per year, but the process is the same. Hopefully this is helpful. Take care. Bye bye.